Hello all. Today I'm going to show you how to do the correlation and regression procedures in SPSS. I'm going to use the Statistics 250 survey data, and I am curious to know what is the relationship between age and college GPA. Okay, is it that the older you are, the higher your college GPA is, or that the younger you are, the higher the college GPA is? I don't really know right now, but I'm going to create a null hypothesis. The null hypothesis is that there is no statistically significant correlation between age and college GPA. Derivatively, the alternative hypothesis would be that there is a statistically significant correlation between age and college GPA. Note that my alternative hypothesis is a two-tailed hypothesis that goes both ways. Either the younger you are, the higher the college GPA, or the older you are, the college GPA. Okay, so we're going to get a p-value that is a two-tailed p-value or probability value. Okay, so I'm going to go on to the Analyze menu, Correlate, then Bivariate. Why bivariate? Because we have two variables, age and college GPA. Bivariate means two variable analysis. I'm going to click on Bivariate, and then I'm going to select age, bring it into the variables box, select college GPA, and bring it into the variable box. Okay, so we have age and college GPA, the two variables that we want to find the relationship for. I'm going to leave Pearson correlation coefficient as it is by default, because we assume that the variances of these two variables are equal. Okay, and then I'm going to click OK. SPSS will give me the correlations table, how age and college GPA are correlated with each other. What we need to find out right now is this correlation coefficient R right here, 0.271. 0.271 gives us a couple of things. First, this is a positive correlation coefficient, which means that there is a positive correlation between college GPA and age. As age increases, college GPA increases as well. But regarding the strength of the relationship, this is relatively a weak correlation because it's smaller than 0.3, right, which is an arbitrary boundary of the weak and somewhat strong relationship, right? So 0.271 is a weak correlation. To visualize that, I can go in and create a scatter plot. Going to Graph, going to Chart Builder, then I'm going to click on Scatter Dot, get the simplest scatter plot, drag it up here, then I'm going to bring age in the x-axis because age is the predictor in this case, the independent variable, and I'm going to bring college GPA and drag it into the y-axis. Then I'm going to click OK. Scrolling down here in the output, and then I see here that these data points are sort of scattered around, and this tells us that this relationship is not very strong. If all these data points were in a single straight line going from lower left to upper right, then we would have had a strong relationship. But these are scattered all around, the graph. That's why visually this is not a strong relationship. Although we can see a pattern. The pattern goes from lower left to upper right, and that's a positive correlation. Moving up again to the most important part, testing the hypothesis, because what we saw is only the strength and the existence and the direction of the relationship. But how about our hypothesis test? The significance two-tailed gives us the p-value of 0.211. This is greater than 0.05, our alpha level. That's there as a significance level by default, 0.05. Since p-value is greater than 0.05, we fail to reject the null hypothesis. Since we fail to reject the null hypothesis, we can conclude that we do not accept alternative hypothesis, meaning we do not have enough evidence to say that there is a statistically significant correlation between age and college GPA, because there is not. There is no statistically significant correlation between college GPA and age. So that's all you can do with a correlation procedure. Let's move on to the regression now. I'm going to go back to the data set. Again, I'm going to use these two variables, age and college GPA. What I want to do right now with regression is predict the college GPA value when I know the age. Okay? Sounds fun? It is. If you remember, the regression equation is actually, let me bring it up here, this equation. Y, or the dependent variable, equals to intercept or constant plus slope times independent variable plus some sort of error. Okay, so y is the dependent variable, a is the intercept or the constant, b is the slope, rise over run, and then the independent variable is x. Okay, we're going to show that to you in a second. To do a regression, we're going to state the null hypothesis. And there are many ways that you can state a null hypothesis. Okay, one way is to say that the null hypothesis states that the variation in y on college GPA is unrelated to the variation in x or age. Or another way to state it is that the correlation between x and y is 0. Or the best probably is that there is no supported relationship between college GPA, between age and college GPA. And we're going to go with this one. There is no supported relationship between age and college GPA. And then the alternative hypothesis is that the slope is not 0. Because when we say that there is no supported relationship between age and college GPA, we are stating that this regression coefficient, b, slope, is equal to 0. Therefore, alternative hypothesis that the regression coefficient is not equal to 0. Okay, moving on to the SPSS. We're going to analyze regression, linear regression. We're going to bring age into the independent box. We're going to bring college GPA into the dependent box. We leave everything else as it is by default. Then we're going to click OK. The regression output gives us 4 tables. The first table gives us the independent variable age that is used to predict the dependent variable college GPA. Then model summary gives us the R, or correlation coefficient, that we saw before. But the most important thing here is the R square, is the R coefficient squared, and that is 0.073. Translated in percentage, this is 7.3, and that means that age accounts only for 7.3% of the variation in college GPA. So 92.7% of variation in college GPA is explained by other factors. Okay? So age really doesn't explain a lot. However, ANOVA, we're not going to linger in ANOVA for this particular example. Just know that significance is 0.211. We're going to go to the coefficients table. This is the most important thing. The constant is the intercept, or A, in the regression coefficient, and that is 2.444. That tells us that when age is 0, college GPA is 2.444. Now that doesn't really make any sense in the real world, but it makes sense when you are trying to predict college GPA by age, because that's where you start. Age 0, that's the constant or the intercept in terms of the college GPA. Moving on to the age, how age affects college GPA. 0.040 is the slope, or rise over the run. For each unit of age increase, meaning for 1 year increase in age, the student will have a 0.04 unit in GPA increase. For 2 years increase in age, an average student would have 0.08. For 3 years increase in age, a student will have 0.012 or 12 increase in GPA. Okay? So that's how it goes. This is the unit of increase in college GPA for each unit increase in age, which is for each year increase in age. Okay? For 1 year older. Moving all the way across to significance 0.211, which is the same as this ANOVA significance here. This p-value is greater than 0.05, our alpha level. Therefore, we retain the null hypothesis. There is no supported relationship between college GPA and age, meaning age does not statistically affect college GPA. Okay? We could have actually seen it from here, R squared. This is 7.3% account in variation, which is not a lot. Okay, we saw it here. P-value of ANOVA for regression, okay, is 0.211. So that's not a significant p-value. And here, the p-value for the slope, 0.211, means that this is not a statistically significant p-value, right? So we fail to reject the null hypothesis of no relationship. So no relationship stands, meaning age does not really affect college GPA. Now let's construct the regression equation. That is our most important thing. Okay, if we're going to go a Word document here, and I'm going to say that the regression equation regarding the null hypothesis of there is no supported relationship between college GPA and age, or b equals 0, is this: y equals a plus b times x. Okay, a is the intercept, b is the slope. So in our case, we will have a regression equation of this nature: y equals 2.444 plus 0.040 times age. Okay, so this is our regression equation. What can you do with regression equation? You can predict, like I said, what will college GPA be for a certain person of a certain age. Let's answer this practical question then. What will GPA be for a 21 years old student? The GPA would be y equals 2.444 plus 0.040 times 21, right? Because age is 21. That's going to be equal to 2.444 plus 0.040 times 21 will be 0.84, right? So we add these two numbers up and we get a number of 3.284. So the answer is the college GPA for a 21 years old is predicted to be about 3.28. So this is the answer to the question about prediction regarding a 21-year-old student. Okay, so that concludes our correlation and regression podcast. Good luck in the final.